All right, guys, next entry, 1 and 2 step inequalities. Go on and put the date for it as 9/21/15, being that that's when we're going to actually do the activity and explore this lesson in further detail. So let's go on and get that written in right now, please. I'll give you a moment to do that. Okay, so it says an inequality is a mathematical sentence that compares a variable and a constant using a symbol, all right? Now, the symbol that we're talking about are your greater than, your less than or equal to, or your greater than or equal to. Okay, so here's our symbols here. We've got the less than symbol, the greater than symbol, the less than or equal to symbol, or the greater than or equal to symbol. Now down here is where we're going to put the vocabulary words, like so if we're reading a word problem, what each term means, okay? So we've got the less than, see the mouth, or equal to symbol, all right? Now obviously we know that means it's less than or equal to, but it can also mean at most, no more than, or like maximum. So let's go on and write those in. Okay, so at most, no more than, maximum, less than, or equal to. And then right here, we've got our greater than or our equal to, which also can mean at least, a minimum, and no less than. Okay, so I see that it's kind of, when I type it in, it's a little bit bigger on the line than what I wrote. You write smaller than what my typing is writing, the font right now, so just make sure that you just have it written and you can abbreviate if you would like to or not. All right, and then the next one is our less than symbol. So that just means less than, below, shorter or smaller than, or under, okay, or fewer than. Fewer than is a really popular one that you would see for this one. So let's go ahead and write those in. Okay. So another one that I just thought of was better deal. So like when you go shopping, you're buying something, obviously the better deal is going to be the item that costs less per each item. All right, so sometimes you have to buy in bigger quantities and spend a little bit more money, but in the end, each item costs way less than what it would if you paid a cheaper price at the beginning. So less than, fewer than, smaller than, and below than, or better deal. Those all represent the less than symbol. Those are just some ways you could see it in a word problem. Okay, now this symbol right here, that's what we're talking about, our greater than symbol, which means, you know, more than, above, over, increased, or higher than. So those are just some words you might see in a word problem to know that if you're writing the inequality, you want to use the greater than symbol. Okay, so I'm going to give you just a moment to go ahead and finish filling those in. Okay, so take a moment and write those all in. And remember that when you're doing these problems, the 1 and 2 step inequalities, we're going to follow those same steps that we use for our multi-step equations as our 1 and 2 step equations. And I've listed the steps on the page for you, so you're not going to need to have to write them out, okay? All right, let's go on and pay attention right here to where these little asterisks are, okay? If you pay real close attention, it says, obviously there's a bunch of them in a row, so that means, look, this is very important. You need to listen carefully. When you divide or multiply by a negative, you've got to remember to flip your sign. Now, it's talking about the symbol, so if it's a less than symbol, you need to flip it to a greater than. If it's a less than or equal to symbol, then you need to flip it to a greater than or equal to symbol. And I'll go into more details with that as we get to problems that have negative signs with their variable. All right, so let's go ahead and read the steps. I'm going to scroll on down so I can look at the steps and read the other asterisks down there at the bottom and then go through the steps. So let me scroll down real quick. Okay, so right here, here's the next set of asterisks that we've got. It says graphing inequalities is easier if the variable is on the left side. It's much easier if it's on the left side because when you have to go and shade, you'll know which way to shade, whether you need to shade right or you need to shade left. Okay, these are the same steps from your equations. If you have any fractions, you need to undo any fractions by multiplying both sides of the equation by your denominator. Step 2, you're going to distribute using your distributive property if needed. Step 3, combine any like terms if needed. Okay, be very careful when you're combining your like terms. If it's a constant, combine the constants together. If it's got a variable, you combine the variables that are alike together. Do not combine your constants and your variables together. Step 4, move variable terms to one side of the equation and constant terms to the other side of the equation. Hint, you need to move the smaller variable, and we've talked about that in class, okay? And then step 5, isolate the variable if there is a coefficient. So for example, okay, if you had like 3x equals 12, you want to isolate that x by dividing the 3 okay? And then do whatever you do to one side, you do to the other. And then step 6, you want to check. All right? So now we're going to go on and move into some examples. Okay? So let me slide. Okay, here's our first example, number 1. X minus 4 is greater than 1. All right, so let's go through the steps that we had on our steps on the other page. Step 1 says that we need to get rid of any funky fractions. Well, there's not any funky fractions there. So next step is to distribute. There's no parentheses, so we don't need to do any distributing. Next step is combining like terms. There's nothing really that I can combine here. And then the next one is to move all our variables onto one side and all our constants onto one side. So right now, I've got 1 over here, my constant by itself, and then over here, I've got a variable and the constant -4. So I want to get rid of this -4, all right? So in order to get rid of that -4 to isolate our x, I need to do the opposite of -4, which is to add 4. So I'm going to go ahead and add 4. And that's going to cancel out. And whatever I do to one side, I need to do to the other. Okay? And it might help some of you to draw the line like down the symbol. So you know that everything over here you need to work first, and then everything over here you need to work, and then you'll go ahead and solve. And 4 plus 1 is 5. So then x is greater than 5. All right? And in the notes, where the asterisks were, it said that you wanted your x on the left because it makes it easier for us to graph. Well, my x is already on the left, so x is greater than 5. So that means any number that I want to plug in place of x has to be bigger than 5. So if I put 4 there, 4 is not greater than 5, so that wouldn't work. That wouldn't be true. I can't even put 5 here actually either, because if I put 5 here, it'd have to be greater than or equal to, and it's not. So it's got to be greater than 5. So 6 would work, 7 would work, 8 would work, anything like that would work. All right, so we're going to go ahead and graph this. Now, like I said earlier, this does not have the equal to part, so this is going to be an open circle. So I'm going to go where 5 is. I'm going to put a circle, and I'm going to leave it open, and then I'm going to shade everything to the right because my symbol, my arrow, is pointing to the right, which means everything to the right of 5 is going to make that statement true. All right, let's go on and go to number 2. Okay, it says -5w is less than 10. So very important. Remember on the notes, there was those asterisks, and it said if you're dividing or multiplying by a negative, you need to flip your sign. So right now, I'm going to rewrite that and flip my sign to say -5w is greater than 10. Okay, so I've rewritten it. And notice I didn't change anything with my -5w, and I didn't change the 10. All I did was flip my symbol. Instead of it saying less than, it now says greater than. All right, so this is a one-step equation, and it's a one-step multiplication. So if I'm multiplying -5 times w, and I want to get w by itself, I need to do the opposite of multiplication, so I'm going to go ahead and divide. So I'm going to divide by -5. Okay, and that's going to cancel out. And whatever I do to one side, I've got to do to the other. And 10 divided by -5 is a -2. So then w is greater than -2. So I can put -1 there because -1 is greater than 2. I can put 0 there because 0 is greater than 2. I could put 5 because it's greater than -2. The only thing I can't put here is -2 or anything less than -2. All right. Also, very important, you want your variable on the left side. So here it is. It's on the left side. So I'm going to go ahead and graph it on my line graph. So put a circle on my -2, and my arrow right here, is pointing to the right. So I'm going to shade everything to the right. And remember, we need to leave our circle open. I know it's not very pretty. Okay, need to leave our circle open because this is not an equal, less than or equal to or greater than or equal to problem. So let's go ahead and shade it. Everything to the right of -2. All right, and we're going to go on and go to problem number 3. Now I like number 3 because now our variable is no longer on the left, it's on the right. And it's also going to have us dividing by negative numbers. So that means we got 2 steps to do with this problem before we can even actually solve it. So first thing, let's go ahead and rewrite it to where we have our variable on the left side of the equation. So let me rewrite that for you. Okay, so far all I've done is just flipped it and rewrote it. Notice that the greater than sign is still pointing to the negative 9y, and the less than part is still pointing to the 27. All right, now I've got a negative 9 being multiplied by y, so that means when I go to divide, I'm going to divide by negative 9. So I need to flip this symbol to say negative 9y is less than or equal to 27. So now we need to flip it. Okay, so I rewrote it. So now I have negative 9y is less than or equal to 27. Now, just like we did up here, we're going to have to divide negative 9y by negative 9 so we can isolate our variable. So let's go ahead and do that now. And that cancels out. Whatever I do to one side, I got to do to the other. So then 27 divided by negative 9 is going to give us a negative 3. All right, and then y is greater than or equal to 3. So now this is an example where you got the greater than or equal to part. So when we go to graph it, we need to make sure to fill in the circle, okay? And we're going to shade left on this problem. So find negative 3. Here's negative 3. We're going to fill that in. That's not very pretty, okay? All right, and the arrow is pointing to the left, so that's why we need to shade to the left. So we're going to go ahead and shade left, everything to the left of that. So right now, what this technically means is the equal to part means I can actually put in negative 3 right there and make that statement true, because negative 3 is equal to negative 3. All right, and I can also put in anything that we just shaded in over here, like negative 6. Negative 6 is less than negative 3. All right, let's go to example number 4. That's going to be, that example is a two-step equation, so you're going to solve it just like we did in class. All right, I've just realized that I haven't been drawing my lines, so I'm going to go ahead and draw my lines right here just to separate it. Whoops. Okay, just to show that we're separating it. Okay, so let's go on and go to number 4. All right, so number 4, let's look at what we have here. We've got 2y plus 7 is less than 17. I don't have a negative with my variable, so I'm not going to need to be doing any multiplying or dividing, so I don't need to flip this. My variable is already on the left side, so I don't need to rewrite it to make it on the left side. So now I'm simply just going to solve this. So first thing we want to do is we want to get rid of this plus 7, and we do that by doing the opposite, which would be to minus 7. Okay, so that cancels out. Whatever I do to one side, do to the other. So now I have 2y. Hang on one. And I've got 2y is less than 17 minus 7 is 10. All right, so I'm multiplying the 2 and the y right here. So I need to do the inverse of that, which would be to divide. And when I divide that, 2 divided by 2 cancels out, leaving me with y is less than. And then now I'm going to go and do 10 divided by 2, which is 5. All right, so this is y is less than 5. So when I go to graph it, because it doesn't have the equal to part, it's going to be an open circle on the 5. And my arrow is pointing to the left, so I need to shade everything to the left. Okay, so shade everything to the left with your pencil. If you want to use markers to make your notes look pretty, I'm fine with that, just so long as you have all the information that I'm giving you. Okay, so let's think for a moment. Could I put 7 right here? All right, if I wanted to, would I be able to put 7 in place of y? Is 7 less than 5? No, it's not. And if you notice, 7 is over here. It's not even shaded. But could I put negative 7? Yes, negative 7 is less than 5, and it's also in that shaded region. So if it's not in your shaded region, it's not going to fit. It's not correct. So that's also another reason why it's very important to make sure that you shade correctly, which is why it's best if you have your variable on the left. All right, let's do problem number 5. Okay. All right, so number 5 says 2x minus 6 is greater than or equal to 2. So let's look at what we have first. Let's see if we have a negative with our variable. Right here I've got a positive 2x, or a positive 2, so I'm not going to need to be doing any flipping of our symbol. Secondly, my variable is on the left side of the symbol, so I'm good to go there. So now I'm just going to go ahead and solve this. So the first thing that I need to do is to get rid of this 6 right here. And in order to do that, I need to do the inverse. So the inverse of subtraction would be to add 6. And that cancels out. And then we're going to do the same thing there. So now I've got 2x is greater than or equal to 8. All right. I'm going to kind of rewrite it over here. Okay. Draw a line to kind of separate that. Okay. So now I need to, in order to solve for x, I need to divide by 2 to get rid of that 2. And whatever I do to one side, do to the other. So x is greater than or equal to 4. All right. So because I've got my equal to part right here, that means that when I go to shade, I need to make sure to fill in the circle completely. So let's do find 4, solid circle. Let's look where our arrow is pointing. Okay, the arrow right here is pointing to the right. So I'm going to shade everything to the right of 4. Okay. So that means that any number, including 4 and everything to the right of it, can be put in place of x to make that statement true, because 4 is equal to 4, 5 is greater than 4, 6 is greater than 4, 7, and so forth. Anything to the left of this filled dot is going to make our statement false. All right? The questions are up on Canvas whenever you get a chance. Make sure you get it taken care of before tomorrow by 9 o'clock. Have a great weekend, guys. I'll see you on Monday.